Hello, good morning, dear students. So, today we are discussing a practical experiment on verification of superposition theorem. As we have already studied the theoretical part of superposition theorem, that is the statement of superposition theorem. After that, the step by step procedure how to solve the superposition theorem. So, today we are going to practically verify the same. So, this is the circuit for practical verification of superposition theorem, and we are also going to see the part of Kirchhoff's law. Now, as I have already told you that Kirchhoff's law and superposition theorem means any circuit, any DC circuit can be solved by any of these methods. So I am using the same circuit to verify the Kirchhoff's law along with the superposition theorem. Okay. So this is the circuit to verify the superposition theorem. So as we can see, there is one 220 volt source connected in series with a 200 ohm resistance. And to measure the current flowing in that resistance, I have connected one ammeter. The range of the ammeter is 0 to 3 amperes. So ammeter A1 will measure the current I1. Similarly, we can see one more source of 110 volts in which ammeter is placed in series with the resistance of 300 ohms. So ammeter A2 will measure the current flowing in the 300 ohm resistance. The range of the ammeter is also 0 to 3 amperes. And in the middle one more resistance, you can see resistance of 500 ohm. That we'll call it as load resistance. Load resistance, that means we are going to measure the current flowing in that resistance, load resistance. So this 500 ohm resistance we are considering as the load resistance, and for measuring the current we have placed one ammeter in series with this that resistance I3, which will show current I3. That range is also 0 to 3 amperes. Now as we know, for superposition theorem, the basic need is, for superposition theorem we know that the basic requirement is there should be more than one source present. More than one source should be present, then and then only the superposition theorem is applicable. Now here we can see that there are two sources. One is 220 volt source, another is 110 volt source. Okay, and the step to solve the superposition theorem is you have to consider one source at a time. Consider one source, measure the current in the load resistance, and at that time the second source should be shorted by a short link. Similarly, step 2, consider second source, short the other source and measure the current in the load resistance. And last step, add that two currents, you will get the total current flowing in the load resistance. Now for the Kirchhoff's law also, we are using the same circuit. So as you know, you can solve this particular circuit using Kirchhoff's current law or voltage law. By solving, you can come to know the current flowing in the load resistance. So while solving with the Kirchhoff's law, you are well known that both sources are being kept active, and when two sources are being kept active, you have to find the current flowing in the load resistance. You have already solved this numerical in the class using Kirchhoff's law also and superposition theorem also. So that were our theoretical values. Okay, the basic difference between Kirchhoff's law and superposition theorem is that in superposition theorem we step by step keep one source active, second source inactive, measure the current, and in Kirchhoff's law we measure the load current directly by keeping the two source active. So finally current flowing in the load resistance by superposition theorem also and by Kirchhoff's law also will be same. So these are left hand side, you can see these are the theoretical values that you have already calculated in the class, while for both Kirchhoff's law and superposition theorem. So applying Kirchhoff's law, any KVL or KCL, if you use, we have seen both. The current flowing in the load resistance, that is total current, is 0.276 amperes. Similarly, for superposition theorem, first step we have considered in the class 220 volt source. At that time, current flowing in the load resistance, that we call it as IL dash, was 0.21 amperes. And after considering 110 volt source, shorting the 220 volt source, the current flowing in the load resistance, that we call it as IL double dash due to 110 volt source, was 0.07 amperes. And theoretically, we have seen that current in load resistance, that is IL, was 0.283 amperes. Now these values of current we have to measure practically. Okay, so for verifying the same practically, I am using the virtual lab. In that, the numerical that we have solved in class, the values of the values placed in numericals, the same values we are placing in the simulator. So this is a virtual lab verification of superposition theorem. Okay, I will directly go to the procedure I have already told you in the class also. We'll go to the simulator. So this is our circuit which I have solved in class, and just now that I have shown you also. So here you can see left hand side is 220 volt source. Now you have the theoretical values of the numerical that you have solved in the class. Compare with this 220 volt source. There is one ammeter A1 0 to 3 amperes which will measure current I1 in the resistance 200 ohm. Second ammeter will measure the current A2 resistance 300 ohm, and middle one ammeter will measure, this is our load resistance 500 ohm, and the current flowing in the load resistance, that is IL will be measured by ammeter A3. Okay. And the right hand source is 110 volts. So this is the same circuit that we have discussed in our class. You have the theoretical values. Now we will see practically the values. So here they have given also the procedure. Now first, in the presence of both the source, that we are, this case one is nothing but we are verifying the Kirchhoff's law. So in case one, what you have to do, you have to keep both the source powered. So here you can see, you can change the switch, short and power. Now we are keeping in power mode only. Second source also in power mode, and we are simulating it. So you will get the current, that is A1. A1 is nothing but our I1. Note down if you want, 0.39 amperes. A2 is the I2, that is minus 0.106, and A3 is the current flowing in the load resistance, total current when both sources are active. Okay, so this numerical we have solved using Kirchhoff's law. Compare with that theoretical and practical value, the value should be same. Okay, so current flowing in the load resistance IL is 0.2838 amperes. Now we will see the same circuit for superposition theorem. We will apply superposition theorem, and our final current, that is IL is equal to IL dash 1 IL double dash, should be 0.2838 only. Okay, now for superposition theorem we know that we have to keep one source active, one inactive. So firstly we'll keep 220 volts source active, and we will inactive second source. So second source we have to short. Now as soon as I short the second source, current flowing in the load resistance 500 ohm will be IL dash. IL dash is nothing but the current flowing due to 220 volt source. Now we'll simulate. So note down this practical reading, that is due to only 220 volt source active, I1 is 0.56 amperes, I2 is minus 0.3548 amperes, and I3 is the current flowing. I3 is nothing but our IL dash. IL dash is the current due to 220 volt source, which is 0.212 amperes. So these are the readings while only 220 volt source or one source is active. Now step number 3, that is case 3. is once now keep 220 volt source inactive, that is short that, and keep 110 volt source active. We will power that source. Now we will simulate. So note down the reading, practical reading. Current flowing due to 110 volt source. I1 is minus 0.177, I2 is 0.2483, and I3 is 0.07 amperes. I3 is nothing but our IL double dash. IL double dash, theoretically we have seen, it is nothing but the current flowing due to 110 volt source in the load resistance. Okay, and as you add these two, IL dash and IL double dash, you will get your total load current, which is nothing but 0.282 amperes. Just you calculate and you can see. Now here, as I've already told you, that this minus sign doesn't matter, it just indicates that the direction of the current that you have considered is wrong. Means current direction अगर आपने wrong consider की होगी तो ये sign जो है वो minus, direction change हो जाएगी तो sign plus हो जाएगी. Okay, have you got it? So this is nothing but the verification of what? Superposition theorem. So this superposition theorem you have seen that we have already discussed in the class, this numerical, and same I purposefully taken that values only for verifying so that you will understand it more clear. Now here you can try any other numerical also, but I will share you this link of the simulator. So here you can replace the values. So instead of 220 volts, you can use your own numerical value voltage. Okay, and you can check theoretically also, practically also, so that you will get the answer. Okay, so this is nothing but the verification of superposition theorem. So I hope you all have understood the same, and you all should you all should practice the numericals theoretically, and same in the simulator you can place the values and you will get the answers also. You can cross verify the same. Okay, so after cross verifying, you can verify the superposition theorem. So have you got it? So this is nothing but all about verification of superposition theorem. Okay, is it fine? So thank you very much.